Welcome back to Everyday Nuggets, where we look into the fascinating world of everyday objects that we rarely stop to think about. Today, we're examining something small but complex: the humble golf ball. More specifically, why golf balls have those distinctive dimples covering their surface is a question that seems simple at first glance, but reveals an intricate interplay of physics, engineering, and sporting history. Golf balls weren't always dimpled. In fact, the earliest golf balls, dating back to the 15th century, were smooth, made from hardwoods like beech or box trees. These wooden spheres were far from perfect. They were easily damaged and didn't travel very far. By the 17th century, the feathery emerged, a hand-sewn leather pouch stuffed with goose or chicken feathers. Still smooth on the outside, these balls represented progress but remained expensive and susceptible to damage. The 19th century saw the introduction of the gutty ball, made from the dried sap of the Malaysian sapodilla tree. Initially, these mass-produced balls featured smooth surfaces just like their predecessors. However, an accidental discovery would forever change the trajectory of golf ball design, quite literally. Golfers in the mid-1800s noticed something peculiar. Their older, beat-up balls with nicks and scratches actually performed better than brand-new ones. The seemingly damaged balls traveled farther and with greater accuracy. This observation wasn't just anecdotal. It revealed a fundamental principle of aerodynamics that would revolutionize golf. Players began intentionally marking new balls with hammers and chisels to replicate this effect. By the 1880s, golf ball manufacturers took note and started producing balls with raised patterns. In 1905, William Taylor patented the first golf ball with indentations rather than protrusions, setting the standard for the dimpled design we know today. To understand why dimples work, we need to explore the concept of aerodynamic drag. When any object moves through the air, it encounters resistance. For a smooth sphere, the air flows uniformly around the front. Still, it separates from the surface at the widest point, creating a large wake of turbulence behind it. This wake creates significant drag, slowing the ball down. Dimples change this dynamic dramatically. They create a thin layer of air that clings to the ball's surface, known as a boundary layer. This layer helps the airflow remain attached to the ball longer before separating, which reduces the size of the wake. A smaller wake means less drag and allows the ball to maintain speed and travel farther. But that's only part of the story. Dimples also affect lift. As a golf ball spins through the air, the dimples help create an uneven pressure distribution around the ball. The boundary layer on top of the spinning ball flows in the same direction as the ball's travel. In contrast, the boundary layer on the bottom flows against it. This difference creates lower pressure above the ball than below it, generating lift that helps keep the ball airborne longer. Modern golf ball design is a precise science. The standard golf ball has between 300 and 500 dimples, with most falling around 336 to 392. The depth of these dimples typically ranges from 0.010 to 0.0100.015 inches. Although this may seem insignificant, even minor changes to dimple patterns can have a significant impact on performance. The difference is remarkable. A smooth golf ball would travel only about half as far as a dimpled one. A professional golfer who can drive a dimpled ball 300 yards would see that same shot travel just 150 yards with a smooth ball, making the game dramatically different. Not all dimple patterns are created equal. Manufacturers spend millions researching and testing various configurations to optimize performance. While most dimples are spherical, some companies have experimented with hexagonal, teardrop, and even tubular shapes. The arrangement matters too. Dimples can be organized in pentagons, triangles, or other geometric patterns across the ball's surface. Some designs use different sized dimples in the same ball. For example, the Titleist Pro V1, one of the most popular balls in professional golf, uses spherical dimples of different diameters arranged in a proprietary pattern to maximize performance. Computer simulations now allow designers to test thousands of variations before producing physical prototypes. This high-tech approach ensures that each new generation of golf balls pushes the boundaries of distance, accuracy, and control. The principles discovered through golf ball dimpling have applications far beyond the links. The same aerodynamic concepts have influenced the design of aircraft, cars, and even swimwear. Olympic swimmers now wear textured suits inspired by shark skin that reduce drag in the water, similar to how dimples work on a golf ball. Wind turbine blades often incorporate surface textures that mimic golf ball dimples to improve efficiency by reducing drag and increasing lift. Some cars have experimented with dimpled surfaces to improve fuel efficiency, although aesthetic considerations have limited their widespread adoption. Golf ball design continues to evolve as technology advances. Modern materials like urethane and complex core structures complement dimple patterns to create balls optimized for different player types and conditions. Manufacturers must balance distance, spin, feel, and durability while staying within the regulations set by golfing authorities. The next time you watch a professional golfer send a tiny white ball soaring hundreds of yards down a fairway, remember that those small dimples are performing a complex aerodynamic function. What began as an accidental discovery has transformed into a perfect example of how seemingly minor design features can have profound effects on performance. In the world of golf, those tiny dents make all the difference between a good shot and a great one, proving once again that in both science and sport, the most minor details often matter most. Thank you for watching Everyday Nuggets. If you enjoyed this episode, please like and subscribe for more videos that explore the fascinating processes behind everyday objects. If you have suggestions for other everyday objects whose history you'd like to learn about, please leave them in the comments below.